Hi, today I'm going to prove this statement. The sum of reciprocal of triangular numbers is equal to 2. Okay, for example, it's going to be like this. We know that 1 is a triangular number, so the reciprocal of 1 is 1 over 1. The next term is 3, so we have to plus 1 over 3. Next term is 6, we add 1 over 6. Next term is 10. The next term is 15, we plus 1 over 15. And all the way to maybe the n term, which is n times n plus 1, because the n term of the triangle number is n times n plus 1 over 2. So reciprocal of this one is 2 over n plus 1, and so on. Turns out to be just 2. Now let's do this. Let's show that this summation is 2. So I want to let Tn be the n triangular number, the n triangular number. So what happened to Tn? Tn is going to be the sum of consecutive number from 1 to n, so we're going to have n times n plus 1 over 2 for any integer, positive integer n. And then we want to find the sum of the reciprocal of triangular numbers. Alright, so let's have this. So we gotta have the sum of the reciprocal of triangular numbers is going to be, I gotta write as infinity, which is equal to the sum of the reciprocal of triangular numbers, which is 1 over Tn from n equal to 1 to infinity. And we substitute this one, which is n times n plus 1 over 2, so the reciprocal, it turns out to be 2 over n times n plus 1. Okay, then it turns out to be the sum from n equal to 1 to infinity. And what I want to do with this, what I want to do with this is to write I want to decompose this fraction. Okay, so we have 2 over n times n plus 1, which is 1 over n times 1 over n plus 1. Okay, so let's try to multiply this. It's like, so try to subtract this fraction. Okay, so we gotta have n plus 1 times n over n times n plus 1, which is actually 1 over n times n plus 1. So what we have to do is to multiply by 2. Okay, so we have to multiply by 2 like this. So actually this term right here is 2 times 1 over n times minus 1 over n plus 1. So it turns out to be 2 times 1 over n minus 1 over n plus 1. Okay, but this is the sum to infinity. We want to write this sum infinity in the limit. Okay, in terms of limit, so we're gonna have k to infinity, the sum from n equal to 1 to k, okay, times 1 times 2 times 1 over n times n times 1 over n plus 1. And then we will find the sum of this term. So it turns out to be limit as k approach to infinity equal, of 2 times 1 over 1 minus 1 over 2. Okay, next term is n equal to 2, so we're gonna have 1 over 2 minus 1/3 plus 1/3 minus 1 over 4 plus 1/4 minus 1 over 5, and all the way to the last term, which is, okay, we might start with k minus 1 term, so it turns out to be 1 over k minus 1 minus 1 over k minus 1. K minus 1 plus 1 is 1 over k. Plus the last term, you're going to have 1 over k minus 1 over k plus 1. Just like that. And then, do you notice something? This will be cancelled, right? Minus 1 over 2 are cancelled. 1/3 are cancelled. 1/4 are cancelled. 1/5 are cancelled. Okay? And 1 over k minus 1 are cancelled. And 1 over k are cancelled. So what we have left is that we have limit of as k approach to infinity of 2 times 1, right? 1 plus minus, okay? 1 plus minus 1 over k plus 1. So it turns out to be limit as k approach to infinity of 2 times 1 minus 1 over k plus 1. Alright? And with distribute number 2, we're going to have the limit as k approach infinity of 2 minus 2 over k plus 1. So we're going to have, okay, we're going to have to distribute this limit. But this term do not have k, so we distribute this limit into here. So it turns out to be 2 minus 2 times the limit as k approached infinity of 1 over k plus 1. So we have the reciprocal of k plus 1 as k approach infinity. If denominator approach to infinity, the whole number here approach to 0. Okay? Approach to 0. So it turns out to be just 2. Therefore, we've just proved that the sum of reciprocal number, the sum of reciprocal of triangle numbers, which is 1 over 1, 1/3, 1/6, 1/10, okay, 1/15, plus all the way to, it may be the k term, okay, and so on. It turns out to be just 2. Alright? So, we've proved that the sum or reciprocal of triangle numbers is equal to 2. Okay? That's it for today, guys.